Using a breaker that accepts 2 wires, sometimes called a double stuff breaker, is acceptable as long as the specific breaker is approved for use in the electrical panel and meets certain conditions. Firstly, the breaker rating needs consideration. The amperage rating of the breaker must be sufficient to handle the combined load of both wires. For example, if each wire is carrying a load that requires 10 amps, the breaker should be rated for at least 20 amps. Secondly, panel compatibility is key. The breaker must be physically compatible with the electrical panel. Electrical panels are designed to accept specific types of breakers. Using an incompatible breaker can create a dangerous situation. It is critical that the breaker is properly installed. This involves securely attaching the breaker to the bus bar and ensuring it makes good electrical contact. Thirdly, consider wire gauge. The wires connected to the breaker must be of the correct gauge for the amperage rating of the breaker. Using wires that are too small for the breaker's amperage rating can cause overheating and fire. The National Electrical Code, or NEC, specifies the correct wire gauge for different amperage ratings. For example, Table 310.16 in the NEC specifies ampacities of insulated conductors. Fourthly, wire termination must be correct. The wires must be securely terminated in the breaker using the appropriate methods. Approved methods typically involve tightening screws to the manufacturer's specified torque. The goal is to ensure a solid electrical connection. Loose connections can cause arcing and overheating. Now let's discuss piggyback breakers. Piggyback breakers are 2 single-pole breakers connected together by a metal bar. They are typically used when there is not enough space in the panel for individual breakers. However, they are generally not recommended for use in residential applications due to safety concerns and potential code violations. One major concern with piggyback breakers is that they can overload the circuit if both breakers trip at the same time. This can cause a fire. The NEC has specific requirements for the installation of breakers. Piggyback breakers may not meet these requirements in all cases. It's best to avoid using piggyback breakers in residential applications whenever possible. In conclusion, using a breaker that accepts 2 wires is an acceptable solution as long as the breaker meets the specified conditions. It is important to consult with a qualified electrician to ensure the proper selection and installation of the breaker and compliance with the electrical codes. A qualified electrician can assess the electrical panel, determine the correct breaker size, and ensure proper wire termination. They can also identify any potential safety hazards and make recommendations for correcting them. Remember that working with electricity can be dangerous. It is always best to consult with a qualified electrician if you are not comfortable performing electrical work yourself. Electrical work should only be performed by qualified individuals. Understanding ampacity and voltage drop is crucial in electrical installations. Ampacity refers to the current carrying capacity of a conductor, measured in amps. It is the maximum amount of current that a conductor can carry continuously without exceeding its temperature rating. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction. To determine the appropriate wire gauge for a particular circuit, you need to consider both the ampacity and the voltage drop. The NEC provides tables that list the ampacity of different wire gauges. You also need to calculate the voltage drop based on the length of the circuit and the load. There are several types of breakers available, each designed for different applications. Single-pole breakers are used for 120-volt circuits. Double-pole breakers are used for 240-volt circuits. Ground-fault circuit interrupter, or GFCI, breakers are used to protect against electrical shock. Arc-fault circuit interrupter, or RFSI, breakers are used to protect against electrical fires. When selecting a breaker, it is important to choose the correct type and amperage rating for the circuit. Using the wrong breaker can create a safety hazard. Electrical panels are designed to distribute electricity throughout a building. They typically contain a main breaker and several branch circuit breakers. The main breaker controls the flow of electricity to the entire panel. The branch circuit breakers control the flow of electricity to individual circuits. Electrical panels should be installed in a dry, well-ventilated location. They should also be easily accessible for maintenance and repairs. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. Electrical systems should be grounded in accordance with the NEC. Grounding electrodes, such as ground rods or ground plates, should be installed to provide a low impedance path to ground. Bonding is the process of connecting all metal parts of an electrical system together to create a common ground. Bonding helps to prevent voltage differences between different metal parts, which can reduce the risk of electrical shock. Bonding should be performed in accordance with the NEC. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning, power outages, or other electrical disturbances. SPD can help to prevent damage to sensitive electronic equipment. There are several different types of SPD available. It is important to choose the correct type of SPD for the application. Electrical inspections are performed to ensure that electrical systems are installed and maintained in accordance with the NEC. Electrical inspections are typically required for new construction, renovations, and repairs. Electrical inspectors can identify potential safety hazards and ensure that electrical systems are safe and reliable. Regular electrical maintenance is important to prevent electrical problems. Electrical maintenance should include inspecting wiring, tightening connections, and testing breakers. Electrical maintenance can help to extend the life of electrical equipment and prevent electrical fires. When working with electricity, it is important to follow all safety precautions. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, or PPE. If you are not comfortable working with electricity, consult with a qualified electrician. Electricity can be dangerous. It is important to take all necessary precautions to avoid electrical shock and fire. Remember to always prioritize safety when working with electrical systems. Understanding basic electrical principles, such as Ohm's law and Kirchhoff's laws, is essential for working with electricity. Ohm's law states that the current through a conductor is directly proportional to the voltage across the conductor and inversely proportional to the resistance of the conductor. Kirchhoff's laws are a set of two laws that describe the conservation of current and voltage in electrical circuits. These laws can be used to analyze and design electrical circuits. There are several different types of electrical wiring available, each designed for different applications. Non-metallic sheath cable, or NM cable, is commonly used for residential wiring. It consists of two or more insulated conductors enclosed in a plastic sheath. Armored cable, or AC cable, is used in commercial and industrial applications. It consists of insulated conductors enclosed in a flexible metal conduit. Conduit is a metal or plastic tube used to protect electrical wiring. Conduit is required in some applications, such as in wet locations or where the wiring is exposed to physical damage. The NEC specifies the types of wiring that are permitted in different applications. When selecting wiring, it is important to choose the correct type and size for the application. Using the wrong wiring can create a safety hazard. Always consult the NEC for specific requirements and guidelines related to electrical installations. The NEC is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years. The NEC is adopted by most states and local jurisdictions in the United States. Compliance with the NEC is essential for ensuring electrical safety. Staying up to date with the latest version of the NEC is important for electricians and other electrical professionals. It is important to note that electrical codes and regulations can vary depending on the location. Always check with the local authorities to ensure that you are following the correct codes. Working with electricity requires knowledge, skill, and experience. It is not something that should be attempted by untrained individuals. If you are not a qualified electrician, it is best to leave electrical work to the professionals. They have the training and experience to perform electrical work safely and correctly. This is especially true when dealing with potentially hazardous situations such as connecting two wires to a single pole breaker. The risk of electrical shock, fire, and equipment damage is significant if the work is not done properly. Always remember that safety is the top priority when working with electricity. Never take shortcuts or compromise on safety to save time or money. It is always better to be safe than sorry. If you have any doubts about your ability to perform electrical work safely, consult with a qualified electrician. They can provide you with the guidance and assistance you need to get the job done right. Furthermore, remember that the information provided here is for general informational purposes only and should not be considered as professional electrical advice. Always consult with a qualified electrician for any electrical work that you need to have done. They can assess your specific situation and provide you with the best solution for your needs. Doing so can ensure that the work is done safely, correctly, and in compliance with all applicable codes and regulations. Electrical systems are complex and require several attention to detail. Even a small mistake can have serious consequences. That's why it's so important to work with a qualified electrician who has the knowledge and experience to do the job right. They can help you avoid costly mistakes and ensure that your electrical system is safe and reliable. So, when it comes to electrical work, don't take chances. Consult with a qualified electrician and let them handle the job for you. It's the best way to protect yourself, your family, and your property. Remember that electricity is a powerful force that should be treated with respect. Always follow safety precautions and consult with a qualified electrician when needed. By doing so, you can help to ensure the safety and reliability of your electrical system. The specific requirements for electrical installations can vary depending on the type of building, the location, and the intended use. For example, the requirements for a residential building will be different from the requirements for a commercial building. Similarly, the requirements for a building in a wet location will be different from the requirements for a building in a dry location. It is important to be aware of the specific requirements that apply to your particular situation. The best way to ensure that you are following the correct codes and regulations is to consult with a qualified electrician. They can assess your specific situation and provide you with the guidance and assistance you need to get the job done right.